Everyone, this is Mohana again. Here we are going to discuss how to factorize the harder quadratics. Now we see this equation on the screen, x square plus axy plus by square. This is a homogeneous expression of degree 2. So what is a homogeneous expression exactly? Okay. Homogeneous polynomial is a polynomial whose non-zero terms all have the same degree. For example, if we take this, polynomial x power 5 plus 2x cube y square plus 9x y power 4 plus y power 5, you can see that in each term of the polynomial, if you add the sum of the powers, then that is same in all the terms and it is 5. It is constant. So this is a homogeneous polynomial of degree 5. Okay. So we can see that sum of the exponents is always 5 here. So whatever is the power which is same for all the non-zero terms, we can call it of that degree. For example, this equation what we have seen is a homogeneous polynomial of degree 2. Okay. Now you can see one more. So this is also almost the same. This is of degree 5. And what about this equation? X cube plus y square. Is this a homogeneous polynomial? No. Why? Because the term power is 3 in one case and 2 in one case. They are not the same. It needs to be same for all the non-zero terms. Now let us see how to factorize this kind of homogeneous expressions, as we feel like reluctant and troublesome. It appears to be a lot cumbersome to factorize these kind of equations. So now let us take this equation. How do you normally factorize this equation? You have to go through a hell lot of algebraic equations in order to factorize this one. But in case of Lopana Sthapana subsutra, what we are going to do is we are going to equate one term equals to 0. And since we have 3 variables here, we need at least 2 set of equations in order to get the proper factors. So in the first case, now we are going to take x equal to z is equal to 0. So when you say z equal to 0, all the terms which contain z, they get nullified. So what are we left with? We are left with 2x square plus 7xy plus 6y square. Now how to factorize this one? This we already discussed in factorization of quadratic equations, and now we are going to multiply 2 and 6 and express in as a sum or a difference so that we get a final value of 7. So we are writing 12 as 4 into 3 or 4 plus 3 so that we can get 7xy in the middle term. And now we must remember that this ratio 2 is to 4 and 3 is to 6 should be same. And when it is same, we get x plus 2y as the first root. And what about the other root? We are dividing 2x square by x and 6y square by 2y. So finally what we get? We get 2x plus 3y as the other root. So we are going to take these two terms and this equation onto the side. And now we are going to equate one more term to 0. Let us say y. Okay. So if you take y equals to 0, then we will be left with 2x square plus 3z square plus 7zx. So now we are going to solve this equation in the same way. So we are going to write 7 as 6 plus 1, and we observe that 2 is to 6 is equal to 1 is to 3. So our root will be x plus 3z. And what about the other one? 2x square by x plus last term 3z square by 3z. So what will that result into? 2x plus z. So now let us take this equation to the side as well. So what we can see, both the equations, we can see that we have 4 factors in which some terms are common. You can see 2x in 2 factors and x in 2 factors. So now we are going to sum this up so as we can get the final factors. So x plus 2y plus 3z, this is one factor, and 2x plus 3y plus z, this is another factor. So our whole expression 2x square plus 6y square plus 3z square plus 7xy plus 11yz plus 7zx can be written as a multiplication of these two factors. So now, in order to understand the proper, procedure, we can look at other problem as well. Now let us take a bigger one. Why it is a bigger one? Because this contains 4 variables now. So when you have 4 variables, you need at least 3 set of equations. But if we put x as 0 or y as 0, and if we take only one term, then it will be a lengthy process. Now in order to quick shorten the process, let us take 2 variables and equate them to 0. So now let us see x and w equate to 0 and all the terms, so that the final expression what we get will be a quadratic expression. So it will be really easy to factorize the quadratic expression rather than the cubic one or the higher one. So any problem we will try to reduce it to a level of a quadratic problem. So this we can write it as 3 minus 2 simply, and we can see x plus y is one root and 3x minus 2y will be other root. Now let us take this on a side, and now let us take 2 more variables, say yw, and then if you nullify all the terms which contain these 2 variables, you are left with 3x square plus 19xz plus 28z square. So how you go? This appears to be a bit complicated, but how are you going to solve it? As we do normally, we will multiply 3 into 28 and we will write subfactors of it. Okay. Now you can check various combinations of these subfactors. 3 4s are 12 and 12 7s are the same product. Now, if someone feels this is difficult, not at all. You just have to be a bit, familiar with this procedure. If you are really familiar with this procedure, you can literally solve any quadratic problem in this world. So now we are going to write 19 as 12 plus 7. And we can also see that why we took 12 into 7, because we are checking actually the terms. We are splitting the middle term so that this ratio will always be equal. 3 is to 12 and 7 is to 28 is nothing but 1 is to 4. So that will be x plus 4z. Now we will divide 3x square and 28z square with x and 4z, and we will get 3x plus 7z. So we are taking off this calculation part and we are writing this term here. Now let us take these two terms, these two factors, whatever we have obtained till now, and clear out the screen, and so that we can continue our process of solving. So now we need one more set of equations, because you can see we have only x, y and z. What about w? We need w as well in the variables. So now we will take y and z so that w will be part of the factors. So we get equation 3x square plus 9xw minus 30w square. So how are you going to factorize it? We do 3 into 30 as usual, and we will take some factors of it. 30 I have split into 3 into 2 into 5. Now I will think of some possible combination which will give me a subtraction or addition which results in 9, and also whose product gives us value 90. So how are we going to do it? We are writing here it as 15 into 6. Okay. So 3 5s are 6. So sorry, 3 5s are 15. 3 into 2, 6. So 15 into 6. So the 15 minus 6 gives us 19. So now we are seeing that this ratio is satisfying as usual, 1 is to 5. So we are getting x plus 5w. And 3x square minus 30w square is divided by x plus 5w, which gives us 3x minus 6w. Now we are taking all these three roots. Let's clear the board. And we are trying to club it. Okay, when we are trying to club it, we get this equation. We take 3x out of, or 3x factors and club it up. 3x minus 2y minus 6w plus 7z. Similarly, x plus y plus 4z plus 5w. Now, we have a small doubt here. What is the doubt? We can take this 3 off from this root. it can be 3x plus 15w into x minus 2w and x plus 5w into 3x minus 6w. So how do you know which one is right? How do we know these factors are perfectly alright? Remember, we discussed cross-check procedure in one more earlier video of factorization of quadratic equations. Whatever that, we are going to consider only coefficients of all the variables, and we are going to cross check that for both factors and the initial equation. Now let us calculate that method, through that method, cross check method. And what are we going to do? 3 minus 2 plus 7 minus 6 into 1 plus 1 plus 4 plus 5. So that we are going to get the product as 2 into 11. Okay. So this will result as 22. Now let us see what this value actually comes out for the actual equation. 3 plus 1 minus 2 plus 19 plus 28 plus 9 minus 30 minus 1 plus 19 plus 46. Now we sum it up all of these, we can see that we are getting a value 92. So our 22 is nowhere near 92. So this is a big wrong. So what are we going to do? We are going to try to change this value and try it once again. So we are going to change it. We are going to take the 3 out and we are going to include the 3 in this one. 3x plus 15 into 7x minus 2w. So now let us add some of the factors again. 3x minus 2y plus 7z plus 15w plus x plus y minus 2w plus 4z. Now let us calculate value for this one as well. 3 minus 2 1, 1 plus 7 8, 8 plus 15 will be 23. And here we will get it as 4. Okay, 1 plus 1 2, 2 plus 2 4. So what we will get? 23 into 4 we get 92. We can see that this value is equal to this value. So finally this is our factor. So this cross-check procedure is really helpful in almost all kinds of equations. Now let us discuss one more example. Okay, this is if someone thinks whether this is a homogeneous equation, you can clearly see it is not. Why? We have a term 4y whose power doesn't equate to other terms. So we can apply this Lopana-Sthapana Sutra to this one as well. We can equate x and y equals to 0 separately and we can get equations. Suppose x equal to 0. Then we are left with 4y square plus 4y minus 3. And we can get values for it. 4 3 are 12. And that 12 you can write it as 6 minus 2. So first root you get 2y plus 3. And again you will get 2y minus 1 when you perform this first and last term dividing with this factor. And now you can see that we have only 2 factors in terms of y. But we need x also. And we have only 2 variables. So now we are going for y is equals to 0. Okay. So when you say y is equal to 0, almost all the terms leave except 3x square minus 3. So that you can sum it up as 3 into x plus 1 into x minus 1. Now if you remember the earlier problem, you can see that 3 can enter either into x plus 1 expression or into x minus 1 expression. But you can see that if you want to sum up the factors, we need to have at least one common term. Okay. So now we are going to have y terms here and x terms here. So what is to be common? The common thing can only be coefficient. So we have plus 3 and minus 1 here. So you can't include 3 in x minus 1. So because minus 3 is nowhere. So you can only include it in x plus 1. So we are going to write it as 3x plus 3 into x minus 1. Now we are summing up the factors. So we get 3x plus 2y plus 3, x plus 2y minus 1. So this is our final product. Now we can apply this method in almost all of the different types of equations in solid geometry, in coordinate geometry, in hyperbola, etc. If someone is interested or curious how we can apply it, then I can tell you some simple solid examples. Now in solid geometry, if you take a cuboid and if you want to calculate the distance between one edge to the other edge, you can say diagonal in 3D. So how are we going to do it? You need to perform a square root of x square plus y square plus z square, which is a homogeneous equation, right? And if you take a coordinate geometry of a straight line, then we are very much familiar with x and y intercepts. And how do we get those y and x intercepts? We equate one of the terms to 0. We will check where they exactly strike x-axis or y-axis by keeping the other term as 0. And similarly, the case of hyperbola. If someone remembers the equation of hyperbola, it is something like x square plus y square is equal to constant. So that is one more homogeneous equation of degree 2. So this is how we can solve all kinds of homogeneous equations. So thank you for listening, and it will be really appreciated if someone can voice their doubts or comments anything in the comment section below. Thank you very much.